All right, this is Algebra 2, 3-38, Part D. And remember, we are solving by rewriting. And we've been talking about that this particular problem looks kind of tough because it has fractions in it. But remember, fractions are really just division problems. And if you want to undo a division problem, you would multiply. And what should we multiply by? And again, we can multiply because it's an equation. If it was just an expression with no equal sign, we could not multiply. But because there's an equation, if we multiply all four terms, 3 on the left, 1 on the right, then we can, that's okay to multiply by the same thing in all four terms. Okay? What do we multiply by? Well, this is being divided by x squared. This term's being divided by x. Remember, x squared just means x times x. So if I were to multiply everything by x squared, or the biggest exponent, then it would also be taking care of this x. Let me show you what I mean. So I'm going to multiply by x, 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 and over here, x, x. Okay? And what you're going to notice is I multiplied by x squared on all the parts. X squared divided by x squared is really a giant 1. And so all that's remaining in the first term is a 4. Don't mind Christmas Chronicles in the background. Then I have an x, x, 12, and x. So giant 1s can be gone. 12x remains. And then here there's no denominator, so it's just 9x squared. And of course, 0 times anything is still 0. Now we're happy that it's 0 because we can factor it or use the quadratic formula. Okay? If I factor this with box and diamond, I put the x squared and the constant terms in a diagonal opposite from one another. In the diamond, I multiply those together to get 36x squared. And this middle term, 12x, goes on the bottom. Two things that multiply to make 36 and add to make 12 are 6 and 6. So those 6 and 6 are what goes in the other two corners. Okay. What makes 9? Well, I could do 1 and 9. I could do 3 and 3. If I look this way, there's a 3 and an x common in both. If I look this way, there's a 3 and x common in both. Okay. And if I multiply 3x times 3x, I do get 9x squared. 3x times 2 gives me 6x. 3x times 2 gives me 6x. And when I multiply 2 times 2, I get 4. So remember, we need to make sure that we are showing we understand 3x plus 2 times 3x plus 2 is equal to 0. And at this point in time, we can use the zero product property. When two things are being multiplied together to make 0, one of those things must be 0. Okay? Now those are both the same. What we are really doing here is we're setting 3x plus 2 equal to 0 and solving. And we don't have to do it twice because those are identical. What we're getting here is what's called a double root. In other words, we have two of the same answer. Negative 2/3, and I'm going to check it on my calculator. Negative 2/3, store as x, and I'm going to check it in the original. 4 divided by x squared plus 12 divided by x plus 9 equals 0. That's how I know that my solution is correct.